Hi guys, hope all of us are doing great. My name is Ernest, and I'd like to welcome each and every one of us to my channel of Ernest Sciences and Mathematics TV channel. I'll request to give a request to our members to kindly go to YouTube, search Ernest Sciences and Mathematics TV channel, subscribe and engage us in the comment section, and also invite our friends to come on board so that we can be having a larger group of members who are discussing these specific topics in mathematics, physics, chemistry, and biology. So today we're going to look at a specific effect of radiation on matter, and I had promised in our last video that basically we're going to look at each set of matter in terms of metals, non-metals, and perhaps specifically for organic and inorganic compounds, ionic compounds, and also perhaps the biological tissue. So in this case, we're going to look at the effect of radiation on matter. And as I said, of course, this we're going to look at in collaboration with the constituents of this specific aspect of matter that we refer to as metals. So in our discussion on the periodic table, we had mentioned a few characteristics of what we refer to as metals. And in this case, we had mentioned some aspects of electrical conductivity, density, perhaps hardness, ductility, and other aspects that I can be able to, of course, mention in this specific case. So that is going to be a basis of discussing the effect of radiation. And in this case, from the kinetic theory of matter, from the basic chemistry concept that we had looked at, I can be able to give an illustration of the metals now that they fall under the category of solids in the three basic states of matter, whereby we're going to see that metals, unlike liquids and gases, they're going to be formed by atoms which are going to, of course, have a solid lattice, whereby the atoms, as we can be able to illustrate, are confined within small spaces and, of course, are arranged in this regular format, unlike the liquids and gases, whose molecules. So this basically solids, liquids, and this is gases for the three states of matter. So in this case, we're going to see that metals have a unique characteristic in a sense that they are made up of a solid lattice of atoms. And so therefore, we are going to look at this specific form insofar as the radiations are concerned. And of course, they are going to, interact with this specific radiation. And the effect is going to be different, as we are going to see later, compared to solids and gases. So if I may expand more, then we have said from the kinetic theory of matter that we can be able to illustrate these atoms as this specific set of particles which are organized, and of course having the bonding which we can be able to illustrate through these specific lines. And from the kinetic theory of matter, we had said that this specific, of course, atoms are in constant motion or vibrations, which we can be able to refer to insofar as their energy is concerned. So therefore, the more the vibrations, the more the movement. And at a specific point when this specific energy that is causing them to vibrate, or the external energy that is causing them to vibrate, for instance, we can consider this one to be like a heat energy that is being supplied to the system, or perhaps to a metallic substance. The bond energy that is keeping these atoms, perhaps atom A and B together, is going to be overcome, and therefore the bond is going to rupture, or perhaps break, and leave them to be free, and they're going to attain a solid state or a molten state. So in this case, of course, we're going to see also that the radiation that is incident on this specific atoms of the molecule are going to assume the same specific analogy, whereby they are going to provide more energy and cause some of the disorientation of these specific atoms in that particular case. So therefore, some radiations, especially which are consisting of heavy particles, we say that these radiations comes in terms of electromagnetic radiations, and some of them are heavy particles like the helium nucleus that we had referred to as the alpha particles. So therefore, we are going to expect this one to be interacting with matter in a unique way, in a sense that due to their mass or the effect of that specific aspect of being heavy, it's going to cause serious damage through the collision with the atoms of an element which is basically atoms of a metal, and therefore they are going to disrupt this lattice network that I've mentioned. Therefore, this is going to result to displacement of atoms from their lattice positions, as we can be able to see later. So therefore we're going to see that the atoms basically are going to be, these bonds are going to be broken due to the intensity of this particular interaction with perhaps the heavy radiations as I've mentioned. And this is going to displace the atoms from their lattice positions and therefore cause that particular displacement. So the atom displacement therefore is going to affect the characteristics of various metals, whereby one of the characteristics that we had mentioned on our discussion of this group of matter that you refer to as atoms, of course, we had said that they conduct electricity. So electric conductivity is going to be affected when this particular lattice has been affected by the interaction with that aspect of the radiation. And therefore, we're going also to see that the volume in that particular case is also going to be affected. Volume is that specific space that the solid lattice of the metallic substance is going to occupy. So the interaction between these heavy particles and this particular lattice of solid atoms of metals is going to be of course affected in the process of interaction with the radiation. And also we're going to see that the concept of hardness of these metals is going to be affected, in a sense that these specific particles are going to, of course, increase this aspect of hardness. And then also we have talked about the concept of tensile strength. So the tensile strength of these specific metals is going also to be affected. So this particular aspect of metallic lattice that I've mentioned, of course, is going to be affected, in a sense that the specific characteristics that I've mentioned for electric conductivity, volume, hardness, and tensile strength are going to be increased in this specific order. But in that particular respect also, we're going to see that other characteristics are going to be decreased. For instance, I can mention one of the characteristics, like the density is going to be decreased. If you consider the density as the concentration of those specific atoms per unity volume, then therefore, due to displacement, perhaps there's going to be increase in volume, and therefore the density is going to be reduced in that specific respect. And the concept of ductility, they're going to be less ductile, so therefore the interaction between the radiations and the metallic substances is going to decrease their ductility in that specific respect. So this one with others, we're going to encounter them. And some of these aspects that we've mentioned for increase in electric or decrease in density and ductility are going to find various applications, perhaps in various industrial processes and in the medical field side we're going to mention later. So that is it for now, guys. Bye, God bless.